Okay, so this video is going to be on the mock test for the Unit 1 assessment for National 5. So this is going to be the answers. Okay, so your first question is saying an atom has 19 protons. What is its electron arrangement? Okay, so we know that protons in an atom are equal to the number of electrons. So that means you're going to have 19 electrons also. Okay, we know that there's a 2 electron maximum in the inner shell, and after that is 8 electrons, right? So your answer is going to be C, because you're going to have 2 and then 8, which takes us to 10. Okay, remember we've got 19, so we're going to have another 8, which takes us to 18, and we still have another 1, which is going to take us to 19. Okay, so it's going to be C. Question 2. An atom contains 11 protons, 12 neutrons, and 11 electrons. Okay, the atom has the same mass as what? So, this is worded a little bit differently. Okay, what you need to know is that the mass number is equal to the protons plus the neutrons. So here we're going to have the protons plus the neutrons gives you 23. Okay, but actually if you look in here, it's telling you 23 protons, 23 electrons, 22 protons, or 22 electrons. Okay, from that, what you need to figure out, or what you need to remember, is that the mass of a proton is equal to the mass of a neutron, which means 23 is going to be the same as 23 protons. Okay, so your 23 neutrons are going to be the same as 23 protons, which is going to give you the answer A. Okay, remember our electrons have a mass of almost 0 or negligible. Okay, question 3. Elements in the same group of the periodic table have the same number of outer electrons. Okay, so remember group 1 has 1 outer electron, group 2 has 2, 3 is 3, and so on. Question 4. Which ion is present in all acids? It is your hydrogen ion, which is your H+ ion. Okay, and alkalis, remember, it's your OH- ion, which is your hydroxide. Question 5. Which of the following substances will conduct electricity? So we know from third year that ionic compounds, when in solution or when molten, i.e. a liquid, are going to conduct electricity, which will give you the answer C, right? Covalent bonding never conducts electricity because we have no delocalized charged particles, and we know an ionic solid does not because the ions are not free to move because they're in a lattice structure. Okay, another one that would conduct electricity would be your metallic bonding. Okay, question 6. Which of the following particles have a different number of electrons from the others? Okay, so your answer here is A, but I'm going to go through why. So actually, if you go to your data booklet and you go to a sodium atom, so we're going to go to our electron arrangement, which is on page 6, and if we go to sodium here, okay, so sodium is 281. 281 tells you have 11 electrons, okay, so I've put 11 down here. When we go to the magnesium ion, remember an ion is a charged particle. So when you have a magnesium ion, this molecule here, this atom here is going to have lost those 2 electrons. So actually it's going to give you 2,8. Okay, remember they form ions to get a full outer shell of electrons, which takes us to your group 8 electron arrangement. So actually when your magnesium loses 2 electrons, you're going to go 1, 2 back up to neon, which gives you 10. Okay, fluoride ion down here as well. So your fluoride, and it's an ion, therefore it's going to gain 1 electron to get 8 in its outer shell. It's also going to have 10 electrons eventually. Okay, so your answer 2,6 is going to be a sodium ion because it has 11 electrons. Okay, question 7. Which line in the table correctly describes an electron? We know that an electron has a negative charge, or a charge of -1, and as I've already said in this video, the mass is almost 0 or negligible, therefore it's going to be B. You just had to pick the correct one there. Okay, question 8 is asking about the average rate of reaction. Okay, Your average rate of reaction, your equation you get in the page 1 of the data booklet, and it is average rate is equal to the change in quantity over the change in time. And it's asking you, during the first 4 seconds, what is the average rate of reaction? So what we're going to have to do is you're going to have to go and find what the quantity is at 4 seconds. Okay, so actually it's going to be 10. If you take it up here, take it along into here, so it would be 10, and it's in the first 4 seconds, so your time is 0, so it's going to be 10 minus 0, because at 0 we hadn't produced any, and your time is 4 minus 0. Okay, that gives you 4 over 10 and 2.5 centimetres cubed, second to the minus 1. And your answer is C. Okay, question 9, which pair of reactants would give the slowest reaction? So you're looking for the largest particle size and the smallest concentration. So your largest particle size is going to be the ribbon, so it leaves you with B and D. And from there you're going to look for the smallest concentration, which is B, 2 molar instead of the 4. Okay. Question 10, which of the following elements are all burned in oxygen? The following elements are all burned in oxygen. Each of the products was added to water. Which oxide would produce the highest pH? Okay, so obviously you can see the answer is D here, but I'm going to go through it. So we know that non-metal oxides, when they dissolve in water, they produce an acidic solution. And we know that metal oxides dissolve in water, they produce an alkaline solution. So from that, we could then take out C, because sulfur is a non-metal. Okay. We need to remember that if it's producing the highest pH, it's going to be the most alkaline. Okay, so the highest alkaline. And we know that zinc and iron are both transition metals, whereas your calcium is an alkaline earth. It's in group 2. Okay, so from that, we can say that calcium is going to produce a more alkaline solution with a solution with the highest pH, because it's an alkaline earth as opposed to a transition metal. Okay. Question 11. Which of the following structures could be used to represent the structure of a covalent network? Remember, we have the covalent network lattice. It is multiple strong covalent bonds, and it looks like a shape like this. This one would be covalent molecular. This one would be your ionic, and this one would be your metallic with your delocalized electrons. Question 12 is a problem-solving question. Okay, so it's telling you the table shows colours of some compounds in sodium. Identify the sodium chromate solution, or the colour of sodium chromate solution. So from this, you're wanting to look at, try and find what colour each of them are. So we know that sodium chloride is colourless. We know that potassium chloride is colourless. Okay, that can tell you that both of these ions are both colourless. Okay, we know that potassium chloride is colourless, but potassium chromate is yellow. If we already know that potassium is colourless, what's causing this to be yellow is going to be your chromate. Okay, copper chloride is blue. We already know that chloride up here is colourless. Therefore, it must be your copper that's causing it to be blue. And now we've got copper, which was blue, and chromate, which was yellow, making green. So it's asking, what colour would sodium chromate be? So we know that sodium chromate, the sodium is going to be colourless, and the chromate is going to be yellow. Therefore, your answer is B. Okay. Question 13. Identify which two ions will combine to form an insoluble compound. Okay, so this is where you're looking for your solubility table, which is on page 8 in the data booklet. Alright, so just work your way through them and see what you get. Your answer is going to be A and F, because aluminium and hydroxide, if you follow aluminium all the way along, hydroxide down, you're going to get insoluble. Okay, so there is your product. Remember, if something's insoluble, you may find a cloudy mixture with lots of particles in it. Okay, so it shows you the shape. So you get tetrahedral, trigonal, pyramidal, angular, and linear. It's asking the shape of the molecule of the hydrogen bromide is likely to be. We know that HBr, so we've got HBr, is going to be D, it's going to be linear. Okay. Question 15. Which of the following pairs of elements combine to form an ionic compound? We know ionic is a metal and a non-metal bonded together, therefore your answer is going to be A, because these two are non-metals. Again, both non-metals, and again, both non-metals. So all of these would be covalent bonding. Okay, section 2. Right, so we have got ethanol, which is C2H5OH, and the alcohol is found in whiskey. A bottle of whiskey contains 230 grams of ethanol, and it's asking you to calculate the number of moles of ethanol present in whiskey. So your first step is to write down your triangle. M is equal to N times GFM. Okay, you are then able to calculate your gram formula mass using your formula. So you're going to have 1, add 16, add 5, add 24, and in total you're going to get 46 for your gram formula mass. Okay, so when you're looking to find the number of moles in your triangle, you're going to cover that over. That tells you that you're going to have to do the mass divided by the gram formula mass. So your mass is in the question, so you're going to do 230 divided by 46, which you've just calculated, and it gives you 5 moles, which is here. Okay, your first mark you're going to be getting for this here, and your second mark you're going to be getting for your answer. Okay, your next one is a titration. So the titration question, first of all, is asking you to calculate the average volume of hydrochloric acid required to neutralise the sodium hydroxide solution. Okay, so from class, you need to remember that you only use the volumes that are concordant with each other. The volumes that are concordant are within 0.2 centimetres cubed of each other. Therefore, it's going to be this one and this one, because this is your final volume used. Okay, when you're doing the average volume, it's just a normal average, so you're going to add them up and divide by the number of numbers. So we're going to do 25.1, add 24.9, all divided by 2. This gives you 25 centimetres cubed. Okay, so then underneath it's going to ask you to do your calculation. So it's telling you from the equation it gives you 1 mole of HCl reacts with 1 mole of sodium hydroxide to give you 1 mole of water and 1 mole of sodium chloride. Right? So your first step is to write down your molar ratio. It is a 1-to-1 ratio. And then you're going to write down what you've got. So you've got NCV, NCV. From the question here, it's telling you 0.1 moles per litre of your hydrochloric acid. So you're going to bung that into your concentration. Okay. The volume that you have just calculated, 25, remember. So you're calculating the average volume of hydrochloric acid, and that's in centimetres cubed. So we're going to bring this down here, 25 centimetres cubed divided by 1,000. We're dividing it by 1,000 to turn it into litres, and it gives you 0.025. Okay, last thing we've got to write down is we've got our volume of sodium hydroxide. So we're going to write down 10. Again, we're going to divide it by 1,000 to put it into litres, and it gives you 0.01. Okay, so our next step is to find the number of moles. We know it's a 1-to-1 ratio, so what we're going to do is we're going to do N is equal to C times V. Okay, N is equal to C times V, so it's going to be 0.1 times 0.025, and that's going to give you 0.0025. Okay, you're then going to bung that in there. 0.0025. Because it's a 1-to-1, we know when 0.0025 of the acid reacts, 0.0025 of the alkali reacts. Now it's asking you, for what we're doing in the question, calculate the concentration of sodium hydroxide. When we are calculating the concentration, we're using our triangle. Okay, so we'll cover up the C because that's what we want, and we're going to do C is equal to N divided by V. C is equal to N divided by V. Okay, we've got our number of moles, 0.0025, all divided by your volume, which you've already got, 0.01, and that's going to give you 0.25 moles per litre. Okay, so that's going to give you your answer. Okay, question 18. Alright, so it's giving you a table and it's asking you to draw a graph. So your graph's out of 4 marks, and I've written down here what we've got for our marks. So your first mark is for choosing the correct graph. Your second mark is for choosing the correct scale. I've already put mine in. Your third mark is for choosing the correct labels and units. And your fourth mark is for the correct plotting. Okay, so I've already put my scale in, and I know that this is volume of oxygen up the side. And that is measured in centimetres cubed. Okay, and down the bottom we have got our time, and it's measured in seconds. Okay, so at 0, 0, it's going to be here. At 10, it's going to be 25. At 30, it's going to be 35. At 40, it's going to be 38. At 50, it's going to be 40. And at 60, it's going to be 40. Okay, so I've now got mark for the correct graph. I've got a mark for my scale, got a mark for my labels, and I've got a mark for my plotting. Now I'm going to draw my line of best fit. Remember, it's not a join the dots. We're going to try and fit it the best that we can into there. Okay, so you would get the 4 marks for that. So it's asking, from the graph, predict the volume of oxygen produced in the first 20 seconds. So we're going to go to 20, we're going to take it up to about here, and we're going to take it over here. So it is about 30. Okay, yours may differ depending on how you've drawn your line of best fit, but as long as it matches up to what you've got, then you'll get the mark. Okay, and your second question is a 3-marker question, which means you need the correct calculation, the correct answer, and the correct units. Right, so calculate the average rate of reaction in the first 10 seconds. So changing quantity over your change in time. At 10 seconds it's 25, so we're going to do 25 minus 0 and 10 minus 0, and it's going to give us 2.5. And remember, your units are centimetres cubed, s to the minus 1. You would also get the mark for centimetres cubed dashed s. Okay, so you're getting 1 mark here, 1 mark here, and 1 mark for your units. Okay, next question then. So, it's telling you about hydrogen and chlorine. It's asking what type of bonding is present in a hydrogen chloride molecule. Hydrogen and chlorine are both non-metals, therefore it's going to be a covalent bond. Okay, if you want to be more particular, it's going to be covalent molecular. Okay, part B, draw a similar diagram to the one above of your HCl, showing all the outer electrons to represent a phosphine molecule. Okay, so that gives you the phosphorus has 5 outer electrons, I can see from the X, so we've got 1, 2, 3, 4, 5, and your hydrogen, you have 1, 2, 3. So as long as you've got 8 in this shell, we're sharing 3 pairs here. Okay, and this is a trigonal pyramidal shaped molecule. Okay, question 20. So it's giving you 4 different types of bonding: discrete covalent molecular, covalent network, ionic lattice, and metallic lattice. It's giving you some properties and it's asking you to match them up to each other. So, the properties are do not conduct electricity and have high melt and boiling points. We know that's our covalent network because no covalent bonding conducts electricity, and high melt and boiling points is due to the structure of the covalent network. Very, very large structure, very, very large number of bonds. Okay. Have a high melt and boiling point and conduct electricity when liquid but not when solid. So as soon as you see conduct electricity as a liquid but not as a solid, you're going for ionic lattice. Okay, that is because when it is a liquid, the ions are free to move, whereas when it's a solid, they are not. Okay, so conduct electricity when solids have a wide range conducts electricity when solid and have a wide range of melting points, When it conducts electricity as solid, the only one you know is going to be your metallic lattice, and do not conduct electricity, going to be covalent, and have a low melting and boiling points, so that's your covalent molecular or discrete covalent molecular. Okay, last question. So you've got oxygen 18 and oxygen 16, okay? Both have the same atomic number, but they have different mass numbers. So what term is best used to describe different types of oxygen atoms? These are called isotopes, same atomic number, but different mass number. And it's asking you to calculate the number of protons and number of neutrons in each, okay? So number of protons are always the same, because if they were different, you would have a different element. So protons is equal to the atomic number. Okay, your atomic number of oxygen is 8, and it's always the one at the bottom. So these are both 8. Your number of neutrons is going to be your mass number minus atomic number. And you can see I've done it at the side. So 18 minus 8 gives you 10, and 16 minus 8 gives you 8.